These are the examples for Geometry A, Credit 5, Lesson 13.1. All right, Lesson 13.1, we're starting our trigonometry credit, and we're going to be focusing on tangent. There's three trigonometric ratios that we're going to be talking about over the next couple lessons. First one's going to be tangent, and then we'll be dealing with the other two in the next lesson. All right, so on example 1 for problem 1, we're going to be finding the tangent of an angle using a calculator. So we just want to familiarize you with how to do that on a calculator on Desmos. The directions are: use Desmos or a scientific calculator to find and write out the value of the following trigonometric functions to the fourth decimal place, and then round to the nearest thousandth or the third decimal place. All right, so let's go ahead and share our screen here for Desmos. And so that should be up in just a second. And let's see, I believe, there we go. I believe that's up. All right, so what we're going to be doing, first of all, for our first example is finding the tangent of 56. So very, very straightforward to do this. So we're just going to type in tangent of 56. Now, what we have to do, we have an answer here, and that's not the right answer. And it's not because Desmos is giving us a wrong answer, but it's because we need to change our settings. There's two ways to measure angles. One of them is called radians. The other one is called, as we're probably more familiar with, degrees. And these angle measurements are given in degrees, as we can tell by the degree symbol. So it turns out that Desmos defaults to radians. And so each time you go into Desmos, you need to change the setting to degrees. So the way we do that is we go to the wrench in here in the upper right-hand corner. We click on that, and notice how radians is highlighted. So we're just going to click on degrees, and that's now highlighted, and we're good to go. And notice the answer changed. It's 1.4825. So we're going to write that out to 4 decimal places, 1.4825. Excuse me, yeah, there we go. Wrote that backwards. 4825. And then they want us to round our answer. And as you can see, the decimal goes on from there. But they want us to round our answer to the nearest thousandth. That's the third decimal place. So we're rounding to where the 2 is here. Now, remember the way we round. So there are options that's either going to stay 1.482 or go up to 1.483. And what determines that is the next number. If the next number is 5 or more, 5, 6, 7, 8, or 9, then that's a go up number, and we're going to go up to 3 here. If it's 4 or less, 0, 1, 2, 3, or 4, then we would stay at 1.482. So as it turns out, our next number is a go up number, so that's going to go up to 3. And so our answer is 1.483. All right, let's take a look at one more. So the next one is tangent of 26 degrees for our next example. And this is, again, for 1 and 2, you're doing the same thing. So both of these examples will serve you to help you for problems 1 and 2. So we're just going to backspace out the 56, put in 26, and notice our answer there is 0.4877. And so once again, we're going to round that to the third decimal place, to the nearest thousandth. Remember, the decimals, tenths, hundredths, thousandths. And so we're going to round to the nearest thousandth. And so remember, the options are to stay 0.487 or go up to 0.488. And we look at the next number. So the third number is a 7. The next number is another 7. That, remember, is a go up number. So once again, we're going to go up to 0.488, and that would be our answer for our second example. So 0.488. All right, so those are the examples for 1 and 2. We are going to, let's go ahead and unshare this right now. And now we're going to take a look at an example for problem number 3. On problem number 3, we want to find the tangent ratio for angle x, tangent of x. All right, let's go ahead and move that over here. So first of all, we need to learn what the tangent ratio is or how we find it. And the tangent ratio is the opposite leg over the adjacent leg. Oops. All right. So remember that the legs, now here's angle x, but let's remind us what the legs are. The legs are the two sides that form the right angle. So those are called the legs. So the tangent ratio is the opposite leg. So now, and again, which one's the opposite leg? Is it this one or this one? Well, it really depends on which angle you're looking at, either x or z. Now, y we're not going to concern ourselves with because that's the right angle. That's the 90-degree angle. So for angle x, our opposite leg, so if you want to, I mean, hopefully we can see it's 30, but to really visualize it, these are the two sides that form angle x. The opposite leg is the side or the leg that is not part of what forms angle x. So that would be the 30 down here. And then the adjacent leg is the leg that's part of what forms angle x. Now, remember, notice we're only involving the legs here. Remember, the hypotenuse is the longest side, so that is not going to come into play here. So the leg that is part of what forms angle x is this here, the 16. So the tangent of x would be 30 over 16. Now, we always want to simplify a fraction. The largest number that we can divide into 30 and 16 would be 2. Just double checking that there. 30 divided by 2 is 15. 16 divided by 2 is 8. Now again, if simplifying a fraction or finding a greatest common factor is something that's still a work in progress, you can, if you want to work it out, which would be best, list out the factors of 30, which are 1 and 30. We'll just do this one time in this video. 2 and 15. Oops, not leaving enough room there. 2 and 15, 3 and 10, and 5 and 6. Get our eraser here. And then the factors of 16 are 1 and 16, 2 and 8, and then 4 and 4. And so the largest number that they have, the only numbers they have in common are 1 and 2. Notice 4, 8, and 16 do not appear up here. Largest is 2, so that's how we know that 2 is the largest number that we can divide into 30 and 16. Again, you can also check that by Googling greatest common factor of 30 and 16. But again, trying to work it out and knowing how to do it's the best way to do that. So for our example, our tangent of x, 15 simplified is 15 over 8. All right, so now let's take a look at an example for problem number 4. Problem number 4 is kind of the same thing, it is the same thing. We're just going to see the triangle oriented just a little bit differently. And so here is our example for problem number 4. So for problem 4, we have this, and we've got x is here, y is here, z is here, and this is going to be 15, 36, and 39. And once again, we want to find the tangent of angle x. All right, so again, angle x is the angle we're trying to find the tangent of. Tangent, remember, is the opposite leg, and we'll just abbreviate that here, over the adjacent leg. So here's angle x. Here are the two sides that form angle x. And so 15 would be the opposite leg, because that's the side that's not a part of what forms angle x. And then the adjacent leg, remember the hypotenuse doesn't come into play. How do we know that's the hypotenuse? Because that's the biggest side. And so the leg that's part of what forms angle x is the 36. And so we have 15 over 36. Lastly, we're going to simplify this fraction. What's the largest number that goes into 15 and 36? It turns out it's 3. 15 divided by 3 is 5, and 36 divided by 3 is 12. So our simplified answer for the tangent of x, and this is our example for number 4, would be 5 over 12. All right, so now let's take a look at an example for problem number 5. So in problems 5 and 6, we're going to be finding the measure of an angle. And once again, we're going to be using Desmos to help us out. So let's take a look at an example for problem number 5. And we have this triangle here, similar or which you have in your packet. This is going to be a right angle, even though maybe that doesn't quite look like one, but we'll say that it is. And then here we have 17, we have 8. And what they want us to do here, and this is labeled as theta, and we'll explain that in a second. And they want us, it says use inverse tangent to find the measure of angle theta, and this is the Greek letter theta, and round your answer to the nearest degree or to the nearest whole number. Okay, so what they want us to do here is not find the tangent ratio. Well, we're going to have to find it, but use the tangent ratio in order to find out what our missing angle is here. Now, you might look at that and say, well, isn't it just angle A? It is, but a lot of times they name angles also with Greek letters. Theta is common, alpha, beta is other common ones as well. All right, so how do we set this up? So what we want to do is not find the tangent of theta or angle A, same thing, but we want to find the angle. We want to find the angle that has a tangent of, and we're going to find out what the tangent of theta is here. So we're going to say the way we indicate that is inverse tangent of theta. So now what is the tangent of theta? Well, again, our opposite leg. So here's theta. Our opposite leg is the 17. And then our adjacent leg, the leg that's part of what forms theta, is the 8. Notice they were kind of nicer. They didn't even, made it easier, didn't even identify what the hypotenuse is there. All right, so what we're going to do now is find the inverse tangent. So let's go ahead and do that. So the inverse tangent of angle theta, in fact, probably a better way to write this actually, the inverse tangent of 17 over 8, because that's the tangent of theta. And so let's go ahead and share our screen again and go ahead and do that. And so how do we do that? So now I didn't close out the Desmos screen, so we're just going to confirm. We're going to go to the settings. We're still set to degrees. So remember, anytime you close your Desmos window, reopen it, you want to make sure that it is set to degrees. So just click the wrench here in the upper right-hand corner, make sure degrees is highlighted. All right, so how do we do this? So we want inverse tangent of 17 over 8. And so we're going to bring up our keyboard. As again, just click the keyboard. And then we're going to go over here to functions. And then right there we see tangent with that -1. The -1 is the symbol for inverse tangent. And so we're going to click that. And now we're going to enter the fraction 17 over 8. Now remember, a fraction bar means divide. So you can just do 17 divided by 8. I'm going to type it on the keyboard here. So 17 divided by 8. And there's our answer, 64.7. Now remember, they want us to round to the nearest degree, to the nearest whole number. So that is our unit spot. The next number, the 7, is a go up number. So remember, the options are stay 64 or go up to 65. So 7 is a go up number. So that's going to go up to 65. So our answer is 65 degrees. All right, so that's our example for number 5. And now let's go ahead and take a look at, we'll do this one more time. So the screen I know is still shared. Let's take a look at an example. Again, finding inverse tangent. And this will, the triangle is going to look like the problem in number 6. So we have 8 and 29. Here's theta. And they also name these with A, B, and C. A lot of times you won't see the letters. Well, we can have the letters, but anyways, here's theta. And so once again, we want to find the measure of that angle. And so we want to find the inverse tangent, in other words, the angle that has a tangent of, now remember, opposite leg over adjacent leg. So our opposite leg, here's theta, our opposite leg is the 29. Our adjacent leg, and again, they don't identify the hypotenuse. It's kind of got to be 8, but let's confirm that. I've got to make that a right angle. So again, that's the leg that's part of what forms theta. So we want to find the inverse tangent of 29 over. All right, so let's go ahead and do that. Go back. There we go. Go back to our Desmos screen. And let's go over again how to type that in. So we're going to bring up the keyboard. Go over here on the right, upper right, to functions. Click inverse tangent, the tangent with the -1. And we want to do 29 over 8 or 29 divided by 8. And that's 74.5. And so 74.5. So we're going to round that again to the nearest degree, to the nearest whole number. The next number is a go up number again. I think everything we've rounded so far has been a go up number. Don't read into that. That's just a coincidence. So the next number after the 4 is a 5. Remember, 5, 6, 7, 8, and 9 are your go up numbers. So what are the choices here? To stay 74 or go up to 75. But since the next number is a 5, we will go up to 75. So our answer is 75 degrees for our example there. All right, so far, 1 and 2, we found tangent using Desmos. In fact, let's go ahead and we'll unshare here. And so 1 and 2, we found tangent. 3 and 4, we found, 1 and 2 found tangent using a calculator. 3 and 4 calculated it from the tangent ratio. 5 and 6, we were able to find a missing angle using inverse tangent. And now our last two on 7 and 8, examples for those, we're going to be solving for a missing side. So let's take a look at an example for problem number 7. And here we go. Here's an example for number 7. So we've got this triangle. And once again, we're calling this triangle ABC. And let's see, in our example, this will be 47 degrees. This is X, and this is 16.3. So this time, as you can see, our unknown is this side length, CA, and that's what we're trying to find here. And once again, we're going to use the tangent ratio to help us out. Now, it won't be inverse tangent because inverse tangent, what we just did on problems 5 and 6, is only when we're trying to solve for an angle. All right, so we have here the tangent of, now we know the angle, 47 degrees. And so remember, tangent is the opposite leg over the adjacent leg. So again, we visualize it, or if we need something to help with the visualization, so these are the two sides that form the 47-degree angle. The opposite leg would be X. And then the adjacent leg, the leg that's part of what forms the angle, is the 16.3. All right, so we've got it set up. Tangent of 47 equals X over 16.3. And now we just have to solve that equation. So X is over here on the right-hand side. Now remember, the fraction bar indicates division. So the opposite of division is to multiply. So the opposite of dividing by 16.3 would be to multiply by 16.3. So the 16.3's cancel, and we have our answer of 16.3 times the tangent of 47. Now for that part, we're going to use our calculator. And actually, let's show you how to do that on Desmos. Let's go ahead and type that in on Desmos. And so let's go ahead and bring up Desmos again. And let's go ahead and get rid of this. And so all we have to do, and again, we didn't close the Desmos window, so we know that we're still in degrees here. And so we're just going to type in 16.3 and then times. Now, if we just put tangent right after that, a number next to a trig ratio, tangent or sine or cosine, indicates multiplication. So 16.3 tangent of 47, and we have our answer there, 17.47. Now this time they want us to round. It says solve for x, round to the nearest tenth, which is the first decimal place. So let's go ahead and do that. We have x equals 17.47. So if we're rounding to the first decimal place, we need to go one more place because that next number tells us how to round. And surprise, surprise, the next number, well, let's back up. Our choices are stay 17.4 or go up to 17.5. And again, surprise, surprise, the next number is a go up number. Remember, your go up numbers are 5, 6, 7, 8, and 9. Since this is a 7, that we're going to go up to 17.5. And so our answer here for our example for number 7 is 17.5. And make sure we can see that okay. Okay, all right. So now let's, for the moment, unshare. We're going to do another example. Number 8, kind of the same thing, but again, just looking at this one more time and also looking at a triangle that's maybe oriented a little differently. And so we get used to seeing however the triangle is oriented or rotated, we can work these problems out okay. Okay, so that is it for that one. Yes. All right, so let's take a look at our last example. And this is for problem number 8. But again, for each pair of problems that we're doing, 1 and 2, 3 and 4, 5 and 6, 7 and 8, like for a 7 and 8, either example is going to help you with 7 and 8. Although, again, 8 is going to be a little bit more directed to the problem that's in your packet. All right, so we have this. We have 62 degrees is our angle down here. This is x, and this is 32. And this, we'll call these A, B, and C. All right, so once again, we're going to use a tangent ratio to solve for x. So we have tangent of 62. Now let's go ahead and write it maybe over here. So tangent of 62 is equal to the opposite leg. So here's the 62-degree angle. The opposite leg would be x, because that's not part of what forms the 62-degree angle. The adjacent leg is part of what forms that angle. So the adjacent leg would be the 32. And so we have tangent of 62 is equal to x over 32. All right, so now x is over here on the right-hand side. The fraction bar indicates division. The opposite of dividing is to multiply. So we're going to multiply 32 to both sides of the equation. So we have 32 tangent of 62 equals, now again, the opposite of dividing by 32 is to multiply by 32, so those cancel out. And we have x equals, again, 32 tangent of 62 degrees. And so we're going to go into Desmos. We'll share our screen once again. And let's go ahead and get rid of this. So we have 32 tangent of 62 degrees. And so we just enter it like that. Even though it's 32 times the tangent of 62, we don't need to type times or put parentheses in. Desmos understands that a number next to it, to the left of a trig ratio is multiplying. And then to the right, it recognizes it as the angle. All right, so we get 60.18, as you can see there. And again, we're going to round to the nearest 10. That's our first decimal place. The next number is an 8. So we can either stay 60.1 or go up to 60.2. The next number is an 8. And yes, you might have guessed already, that is a go up number. And actually, let's go ahead and stop sharing our screen so that we can see up here a little bit better. So again, we have a go up number. And remember, 5, 6, 7, 8, and 9 are your go up numbers. So we're going to go up to 60.2. And so our answer here, x, the measurement of x is 60.2 units. All right, that is it for the examples for 13.1. As we always say, pause, rewind the video as needed, and I'm sure you'll do great with these problems. All right, so that's it for this video. Until the next video, take care and God bless.